Welcome to It's Friday with Blades and Amberskies. Yep, I'm back. We're still programming, and this is a C++ game club. It's for you. Anything you want, you can have it. We don't mind there. Let's switch the music off. I'll keep it selected just in case we need it later. Why not? Oh, I've got console log. No, I don't want that. Yes, I might. Okay. Everything's set up. As you can see, Wednesday finished on a non-working thing, so I decided to show it working. It works in 2D, and it also explains why it wouldn't work for me on Wednesday. Because I forgot something. So here it is. I've transferred our movement component from our ECS into a 2D program. So there's only X and Y. Exactly the same kind of things. Clamp to max velocity, update, decelerate, and final movement of, in this case, a sprite for 2 dimensions instead of a 3D model. So that's the only difference. The rest of the code is exactly the same, and it fits in to the code under entities, which is here. And I'm on that side, aren't I? Here we go. Show all this first. Get it all out of the way with. So it does fit into the entity, and it comes in with the sprite, a movement component, set the texture for the sprite, create movement component with acceleration, deceleration, set position, move, update and render. And on the left hand side we have, nothing very complicated going on here. Creating the movement component is just literally what it says. Setting the position, X and Y, exactly what it says. You just transfer this into 3D and it will work fine. So the same here, and update and render. So this is where the sprite is drawn. This is where we should be instructing our main state or game state in the 3D to draw or render this target, or adding this to the render list of entities. So that's what this would do. Now, does it alter anywhere else? Actually, no, not really. You can go through to avatar, and under avatar there's not much in the change here. Set texture, set position, sorry, init component, set texture, set position. That's all we've got. And all we're doing is taking them from the avatar constructor. Initialize the components, there we go. I just put 100, 20 and 10 in. Accelerates at 20, decelerates at 10. That's in pixels. Pixels per delta time. Remember, it's times by delta time. So it'll be a very small amount. Anything else changes there? Yes, the avatar setup now looks slightly different under... no, it'll be states, won't it? Game state. So under game state, what we have here is init players. So everything else is literally the same. Player move O-1. So that's for whatever it's key pressed to. Move forward. So that's the Y direction. Forward is downwards, I suppose. I don't know. No, forward is upwards, sorry. Let's move up. That's the same. That's the same. I've got my GL states protection here for the render target due to the fact that I'm mixing now a sprite in. That's not needed in the 3D one. Init key binding's the same. Init textures and init player 50/50. That's its position. Texture player idle, whatever that texture is. Have I? Yeah, init textures player idle. Load from file. Testbob PNG. Alright. Yeah, that's a simple texture. Right. When you run it, and it compiles, here we go. So as you can see, this is my testing laboratory for 2D. This is solo game. Here it is. Here's Bob. And when you press D, it doesn't just. There's a sluggishness to it. So it's a little bit sluggy. So can you see where I went wrong? Where is the camera? Well, the camera is in the center here and up out of the screen, and we're looking down upon Bob. So the camera is static and it's Bob that's moving. And that's why nothing happened. Because our avatar isn't Bob. Our avatar is a camera. And that's where I went wrong. There we go. So that's why I didn't really get very far towards the end of Wednesday. Shame, really. There we go, close the solution. So let's go back to development, shall we? Let's see what we do have. So this is our development. Hopefully I've reset it back to what it should be, and we now have a component that we tested but not in 3D, and I can see nothing. Why can I see nothing? Because I've altered it. I've been looking at this. The avatar doesn't need an entity, so there's nothing to see. What we were looking at before was ourselves. So if I comment out those, oops, wrong one. There we go. What happens now? Do we see anything? No. There's no entity allocators going on now in Avatar. So in Avatar H, I would have to do that as well. See, all I did was take the base entity off and see where it left us. And it leaves us back here. So what we're actually looking at there is not what you think it is. What we're looking at there is our test piece. That's what we are. That's what we look like to other players, not what should be on the screen. What should be on the screen is setting a scene. So that's what we're going to do today. But bear in mind, at some stage we're going to throw him away, because he's not real. That's just a test piece. And it also means that this will no longer be a base entity, because it doesn't need to be. In fact, if anything, it should say there, camera 3D, if you think about it, because that's really what we are. We are the camera. So we're on a first-person shooter type of camera, if that makes any sense to anybody. I hope it does. And I didn't get any comments about this colouring thingy. I've tried to increase the contrast a little bit, but we'll see how that goes. And that's the end of Wednesday. All the explanations have been met. What are we doing today? Good point. Dunno. We'd better do something, hadn't we? Shall we have this in the rendering with our base entity and everything else? I think we shall. But that'll be in Amber, won't it? Alright, shut Amber off a minute. going to go for entities with this. Yeah. There's a lot of thought is going to go into that bit there. I'm still thinking about it. That's why I'm hesitating. I do apologise. So oh, hello, viewers. Good of you to join us. Thank you. Thank you on a Friday afternoon. What are we going to do with this? Alright, let's do a flat terrain. Namespace RPG. We are using that all the way through, aren't we? Yeah, okay. Yeah, we are. Okay. Let's clear the table. Yes, I was looking through an awful lot there, trying to think of should we have our avatar actually carry a model or not. Not sure at this stage, so I'm probably going to knock the model off and just make it simpler. Entities, we will have add new item, and it will be a header file. Let's be original, shall we? Let's have terrain. Terrain.h. There we go. Let's set this up. Hash include. And I'm just going to take the normal ones that I usually do, which is Amber. And that's just system includes. Because I'm lazy. Namespace is going to be RPG. And class is going to be terrain. Lovely. Is it happy? Okay. I don't know what that marker is for. I don't think it does either. Excellent, let's save that out. Solution Explorer, yes, with the terrain.h, I think I'm going to have a CPP file. So let's do that then. We may as well add it now. There's going to be one. No doubt about that. So let's have a terrain.cpp. Nice, sliding into this nice and gently today, I think. There we go. Hash include, and it's just going to be terrain.h. Namespace is going to be RPG. And that's all I need, really. Yep, that'll do me. Alrighty. Let's see now, what will we have today? Oh, yes. Right, I'm going to include a couple of extras, I think. So from Amber, let's include a couple of extras because we're going to need it for terrain. We will definitely need Amber. What will we need first? Models rendering. Yeah, let's take the models. That's got some good stuff in it. So we'll have stuff from there, I think. And we, oh dear. And we also will need amber. Yes, folks, I can't spell today. Hash include, and it's going to be awkward with me. God knows what I've done there. Hash include. And it's amber. We are going to have to transfer data over to OpenGL, and I think I will find that in here. Yes, I will. So let's have a look at variables. Let's cheat. Let's cheat a little bit. Const expression float. And I'm going to have terrain size. And to start off with, does it really matter? It does. But how much? Alright, I'm gonna be conservative. Because I want to do 1000 by 1000, don't I? 1000 meters by 1000 meters. That's the terrain size, that's the goal size. Alright, let's do that then. Right, so that's going to be our terrain size. We're going to also have to set a car. I've done something wrong. It's const expression, isn't it? So const expression again. And we are going to need an int. And it's going to be vertex count. Well, it's not really going to be vertex count, but it's going to be the number of vertexes down each side. I'll call it vertex count because it's going to be simpler to type, rather than vertexes down each side. What should we equal that to? Something divisible by 1000, probably. It's going to go from 0 to 999. Let's have 100. See what 100 does. So 10 meters by 10 meter for each tile. Yes, that'll work. Not F. Well, it'll work initially, shall I say. That might have to go up to 1000 to match. I wonder if it'll cope with that. Because what we have to do is create a model and load it onto our graphics card. Instead of taking an OBJ, which we could do, I suppose, and just take an OBJ and load it up. Make 1000 by 1000 square in Blender. I think we should test both. So let's have an m_position x. That's probably going to be wise. And let's have a float m_. This isn't. Yeah. I'm just wondering whether to call it Y or Z. I think it's Z. What have I got in my notes? Well, I've put a Y in my notes, of course, haven't I'm trying to think how it's going to affect us. I don't think it will. Right, no. It's a Y. And that's completely counterintuitive. And I know it is, and I apologise for that. It should be a Z. Right. I've made an alteration to my notes. There we go. Sorted. My notes are now correct. And it is position Y. Right, this position is the position of the map. So position of map in from Atlas. Remember, we're going to have thousands and thousands of maps from Atlas. Yeah, that'll do. Well, yeah. I'm umming and ahhing again, aren't I? I know. Just trying to do this so it's readable, really. So, there we go. Alright, so we'll have that. And we are going to need a model. So we can take that from world models. Good. And that will be Amber. Model. This is what we have to create. Model. May as well call it a model, after all, that's what we're creating. I think that's going to be roughly about it. As long as we have the location of the top left-hand corner from our atlas, which is in 2D, it'll look like pages like this, our maps. So you'll have one map is on the left, one map is on the right, and they'll be stacked in the atlas. And of course, the atlas will just be a two-dimensional array. To be quite honest with you, well, you can calculate it because of that figure there. So every 1,000 units across, there'll be another map, and another map going off the right, another one going off the left, one going off the top, bottom, and the same here, top, bottom, left. So you're joining the maps to make one big one. And I think 1 kilometre is about right for now. For testing, anyway. Public. We'll just have terrain, I suppose. But what should we have? We'll need that atlas. So it's going to be atlas X and atlas Y. In other words, which map is it? So that we'll need. What else will we need? We'll need some way of loading it to the graphics card. Now I've already made one of those ages and ages ago in Amber. We did it for the OBJ objects from Blender, so I may as well use that. So it's store object data. Okay, and what we're going to do is we're going to call that loader. That's going to load our information up to the graphics card. It was designed to do that, so that's what we'll do. I'm going to include a texture ID. And I'll even spell it right if we're lucky. So we'll have one of those as an unsigned int. And it is going to need an unsigned int UUID, so it is going to need a unique universal identification number. This is the second time we've come across it, and now we have to do a UUID. I wouldn't call it a class, but a tracker. So there is that. Why can't I have a uint UUID? U is unidentified. Really? Fine. Whatever you say. And yeah, I think we'll have one of those because it's going to have to put something in there, aren't we? There we go. So that's popped in there. Okay, what else are we going to need? We'll need a destructor because we've got a star in there, at least one star. So let's have a destructor. We'll have it a virtual one again. Terrain. I'll do that. I'm surprised nobody's asked me about this yet. Really, I'm surprised. But anyway. And this can construct and destruct, and what we'll do in private is, is what the function really is all about. So I may as well make that bit private. And that will be Amber model star generate terrain, open brackets, and all we'll need is the Amber store obj thingy, and a star loader. Yeah, that'll do. Semicolon that. And we can generate that. Lovely. Well, that was painless. A lot easier than I expected. Normally I'm struggling to think of things. Thinking of things to do. Let's pull these down. So we can see everything. There we go. General pointer, yep. And we do have an auto deletion here, haven't we? Delete. What did we do? Model. Not really sure, but yes, we do need it. Ah, do we? We're assuming that we're keeping the model around. Possibly not then. Okay. That was an interesting thought I just had. Why are we going to be keeping the model data? I don't think we need to. Once we've loaded it, we can delete it. We might not even need to return it. Ooh. Thoughts. Okay. So I'm thinking a little bit about that. Why have I got this here? I don't know. Okay, let's get this all set up, shall we? So, we've got green squiggly lines which says do stuff. What it's really saying is return that and put a colon and let's do stuff. So what do we need to do? We need, from the top, M position X, And we're going to make that equal to atlas x times terrain size. We have to know where the top left-hand corner is, and that's where it is. Okay, that's fine then. M underscore position y in the atlas. I don't know whether to change it to Z or not. Is it easier to think of it as X and Y, or is it easier to think of as X and Z? When you think of maps, you think of them in 2 dimensions, something on a piece of paper. I'll keep Y. It's confusing to me, but I think it might not be confusing to everybody else, if that makes sense. I can always change it. Unless Y. Ah, well, you know what's coming up here. Terrain. Size. So that's that done. Right. What we're going to... I am going to have to put that in. Initially. I have no way of telling at this point if we are going to be keeping anything or not. We've still got green squigglies going, so there must be another comma to do. And that's M model, isn't it? Well, no. No. I'll do M model below in here. This isn't going to be like a normal one that I do where I just do an empty. I'm actually going to specify when it's constructed, all the details, and generate the terrain, because we need it all to be done and dusted, and then we can use the model. We're not hanging around saying, please, you know, like, make this object, initialize this object, create this object, delete this object. We're not having that functionality involved. We're just saying, I want a terrain at this location in the atlas. I think that's an easier way of doing it. Alright, let's see if we can get this done properly. So we will have M underscore model. Oh, I've just caught up with myself. Yes, we do need delete model. What can our model do? Well, we need to generate it first of all. Generate model, or generate terrain, I suppose. And that's going to use the loader. So we'll have that first. So that does that. That green squiggly should go away now. So M underscore model, let's fill it in, shall we? It's a structure and has normals. Okay, we'll do that. Equals, well, we're going to create some, so that's going to equal true. What else is our model going to have? Will it have textures? I asked for a texture ID, so yes, I'm going to have textures. Why not? We'll deal with you when we come to you. You're going to be awkward. True. Did I do minification and maxification? Ooh. I don't even think we touched on that. That'll be interesting. Okay. Let's see what's next. M underscore model. Done texture. Index count. We won't be doing here. Texture ID. Yes, we've got that. Let's do that one. Equals texture ID. There we go. We can do that one quite easy. Anything else we might need? So we've got texture ID. Have we got a UUID? Yep, we'll need one of them. Lovely. Anything else we might need? This list is getting... Oh, reflectivity and shine damper. I'll use the standards. 2.0F. Why not? It can be changed outside of the model, outside of this function. It can be changed anyway. Model. What we got now? Shine damper. Okay, we'll keep that low as usual. I don't want too much shininess now, do we? We don't want plastic floor. I think that's about it. Let's just check. No, I don't know the VOID. That's going to come from the generator. So there's two things we want from the generator. We want the VAO ID and the index count. So those are the two things that we don't know. Okay, let's do this as I normally do then. And I'm just going to make a note here. Provides an index count. And VAO ID. Alright, so that's what we need to provide in here. This is filling out nicely. Okay, now I was thinking about doing this, you know, just straight, the proper way. And, you know, just thinking about it, I thought, okay, how would you do it in... I've been doing JavaScript a little bit. Sorry, Java and JavaScript now. I've been doing Java a little bit. And in Java, you would do something like... let's go back up a line, I think. There we go. You do something like int count, and then you'd be doing things like vertex count times vertex count. I think you would. Yes, you would. Okay. And then what you'd do is you'd use that count to initialize your variables. Okay. And your variables in Java would look something like that. And that would equal a new float. Count times 3. Because there are 3 vertices per vertex. And we know how many vertices there are. That's count. So that's how it would look in Java. Now, I'm going to copy that into C++. I don't need int count because you're not allowed to do it that way. When we are defining arrays, which these are arrays, that's a Java array. Let's just put it there. Okay, so that's a Java array. A C++ array, you need to know at compilation time what its size is. So you need to know before you compile. So I can't put int count equals that times that. Even though it's a constant expression, it will be illegal. because count is a variable and could have changed before or by someone else before it gets to here, whereas vertex count can't be changed. It has to be, well, it can't be changed by anybody else here. They have to come up here and change it and recompile. So that's why that's a constant expression. It's so that we can use arrays. This is so funny. Vertices. Now to do the array, we can't use count, so we're going to have to do vertex count times vertex count times 3. So it's exactly the same line, and there you go. There's your vertices. That's handy. I'm going to take that vertex count back and vertex count. I've got a feeling this is going to crop up a few times, because that's the way, you know, it's just giving you a hint. It's going to crop up a few times, you know. That's why there's that extra int there. So float normals. We'll create some of those. How many shall we create? I think we'll have one normal per vertex. We're going to, yeah, that'll do. Times 3. Fantastic, we're getting somewhere. What should we have next? Texture coordinates for the texture. We'll have to generate those. And we are going to generate 2 texture coordinates per vertex, and it's going to be an X and a Z, isn't it? Yeah. Okay. So we can represent that as that times 2. So that's how many of those we're going to have. What else shall we have? Oh yes, we want our indices. And how many of those are we going to have? 1, 2, 3, 4, 5, 6. We are going to have 6 because we need to create a box. Right, there's my pen. Come here, pen. Let me explain what I'm trying to say. Here we go. Blue will do, I suppose. We're using blue, so let's use blue. Oh, we've got a dark one there. That's good news. Alrighty. So what we're going to have... Oh, it's not plugged in. Of course it's not. Will it register? Oh, there's that noise. Yeah, it will. Thank God for that. I've forgotten to plug my pen in. So how we are going to be generating it is we're going to have the top left hand corner here, and this is going to go into a triangle. Muppet, no, Muppet, stop it. Please. Come on. Thank you. So we need to create this in triangles. So there's our other dot, and we go back to there. And then our other one is going to be from there, down the line, across and back up. We're going to have 4. But that's 1, 2, 3. 1, 2, 3. So that's where the 6 comes from. And all we're going to do is go across here, doing that. So, like that. Okay, and then we'll build up the map by going down and making more of them. like that. Okay, and this number that says vertex count over here, 100, we're going to have 100 of them there, and we are going to have 100 of them going along there. So there's going to be 100 squares by 100 squares, and they're all going to cover the total size of 1000 by 1000 units. So each one of these squares is 10 by 10. And the cats are now eating my pen. Thank you, Muppet. Oh, I better keep hold of that. It seems that Muppet wants to eat... Oh, God. Eat my pen. How's about you don't? So that's how that's all going to be generated. That's what we're looking at. So I'm going to try and keep it as simple as possible. Let's just pop that over there. Okay. And can I have my mouse pointer back, please? Thank you. I'm going to have to move the cat in a minute, I think. So, we've got 6. To make a full square, we need 6 indices. We need 6 points. Well, then we need to times that by... This is where it can get tricky. Muppet, that's the microphone. He is looking for a lot of attention today. Thank you, Muppet. So let's put that vertex count in here. But there's a problem. And it's only a small problem, luckily. If you can remember, computers start at 0. So we're going to go from 0 to 99. Yeah. And that's what happens. And then we've got to multiply that by the other side, which is vertex count minus 1. So, not too bad. Just as long as you remember that we're starting at 0, we're fine. That's not a problem, because the first map coordinate will be 0, 0 in the top left. And then it will be 1000, 1000. So the actual right-hand part here, where they join, will be at 999, 999. So yeah, we might get a gap, but we'll see. We'll see if I mess up. Probably will, knowing me. And I'm going to need a pointer. What type? I'll just have an int. Why not? I'll call it vertex pointer. So we know what it refers to. It's just going to point along each vertex in turn. So I know it's just so I know which vertex we're dealing with at any one time. And now comes the fun for next loops. This is nice. It's quite standard. It's quite easy to understand. What we're going to do is a double for next loop and just go square, 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 down 1, square, 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 down 1, square, 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 down 1. That kind of thing. It doesn't matter which way around the for loops are. So as long as you cover all the squares and you generate them all, it doesn't really matter, because your indices will follow, as we'll be doing those after this in the same way. Okay, so I equals, this time I'm using an I on purpose, because that means I'm being mathematical instead of using an index. As long as I is less than, you guessed it, gets used a lot, doesn't it? This vertex count. So in other words, 0 to 999. Or sorry, 0 to 99 in this case. Okay, see, it says it's 100. Right, I++. That's the first one. Oops. Four. And in maths, what comes after I? Int j equals 0. Semicolon. As long as it is, I'm going to do less than again, yeah. Vertex. Count. Yeah, that'll do nicely. And that's j plus plus. Return. And there we go. We can now do our calculations with I and j in mind. These calculations are going to get a bit tricky, so I'm switching this one off. There we go, we'll go to full screen on this. Let's start with the vertices. So we are going to have 3 vertices per run, and which ones are we going to do? Vertex pointer. Oh, sorry about that. There you go. Have a vertex pointer, why not? So start at 0. And we're just going to keep multiplying that by 3. Tell them on a British keyboard there. Oh yeah, I need to multiply by 3. Am I on insert or delete again? Keep knocking those. Right, let's take that little bit. Just copy it a second. Never do this at home, girls and boys. Never do this at home. Okay. And it's going to equals. The fun bit. I'm going to abbreviate this to C. Just so you can see what's going on. First of all, we've got integers here. Well, we're actually dealing with integers. So we're going to have to somehow convert everything to floats, because we're going to be storing floats. Is it wise having these as integers then? I'm just thinking about multiplications and everything, because there's going to be a lot of multiplications coming out of this. And in floating point, that's expensive. I could change these to a float. No. I'll do it the quicker way. Float. Alright, so I'm going to have to change it to a float, and that is going to be j. And then we're going to divide it, and this is why I didn't put it to a float there. Floating point division is a nightmare. So j divided by float again. And it's just going to be vertex count minus 1 and that's going to be multiplied by terrain thingy. There we go. Terrain size. Is that the whole thing? Let me just check on my notes. Yeah. I think we're safe with that one. Yeah. That will do it. That's the X position. The Y position, the up and down position, is easy. Have you noticed there's no squigglies come under here saying, oh, you have to do static cast? Oh boy, that's going to come up. Yeah. Okay, can move down one, and we can do the last of our vertices, which is the other one, which means it's the opposite, isn't it? So it's float, and we'll be using I this time, and we're going to divide that by float vertex count -1. And that is going to be multiplied by the terrain size. There we go. Now, have I done something wrong there? Yes. I have. I haven't increased the vertices, so that's going to have to be +1. So that's the X, that's the Y, and the Z will be +2. So we're doing 3 at a time. There we go, that's better. Now it looks right. So that's your vertices. What's next? Normals, okay. And inside there it's going to be, guess what? Yeah. I'll do them one at a time now. And that is going to equal, the base one is going to be float for J. Oh, wait a minute, these are normals, aren't they? Well, they're all the same. Sorry, my bad. We can assign these. We know what the normal is to a flat surface that's on the ground. It's directly up, which is 0.0f there. Oh, this is a nice one. I like doing this one. And then it's vertex pointer times 3 plus 1 equals 1.0f upwards. That's the y direction is up. Normals. Oh, I like this bit. The normals will change if you change the shape of the terrain, and that's when it starts getting a little bit more complicated, shall we say. But we're going to be doing that, so don't worry. I'm not going to have a flat world. Well, after modifications anyway. Let's do that. So that was easy. What comes next? How's about texture coordinates? And we're going to have vertex pointer times 2. And that's going to equal something silly. It's going to equal the first part of the original. So it's going to be float j divided by that without terrain size multiplied. The texture coordinates are to do with the square you are currently doing, not the whole terrain. So let's do that. So it doesn't cover the whole terrain, just the square that we are currently making here. That should work. Tell me if it doesn't. Okay, I think think it does. Texture. There's only 2. But which 2 do we want? I think we want the X and the Z. Yeah, I think so. Okay. So that's times 2 plus 1. And that equals the other one, doesn't it? So I can just take that straight from here. Magic. There we go. So those are the equations. And after we've done all of that, all we do is say vertex pointer plus plus. That's it. That's your for next loop. Do we need to reset the vertex pointer? Yeah, we do. I don't think we do. We'll see. Alright, I'll need a new one though. Yeah, I'm going to take a new one. I'm just going to call it pointer this time, because it's generic. So we'll have a new one anyway. It saves us making mistakes, I guess. Oh, this is going to be fun, isn't it? We've got our vertices, we've got our normals, we've got our texture coordinates. What don't we have? We don't have our indices, do we? So we've done up to here. So really that it's still... What is wrong with that line? Nothing. I'm going to cut it. So this all belongs together. Like that. And then we're going to do a second one here. Yeah. So let's do these separate. Lovely. I think that's a better idea, isn't it? If we keep everything separate. Right, indices. I want Z and X. I don't want to call them Z and X though. What can we call them? Point indices IZ, IX, indices Z. Because what we've got to try and do is draw a square. Properly. And that means... Oh well. Well, I'll think of something. I'm just going to call it X and Z, aren't I? Yeah, why not? Okay, int Z. There you go, I've called it Z now. Equals 0. Arguments I have about this. As long as Z is less than the vertex count. Okay. And it's -1. That's my Z. So used to having X's. doing it the wrong way round. For me, but anyway. For int x equals 0 and x becomes less than vertex count. Darn it. Count -1. Yeah. I am still having a slight internal argument about whether I should be doing it that way or not, but hey ho, we shall see. Right, so there are, on a square, there are 4 points. We have to change 4 points into 6. So, okay, here goes. Int top left equals and it's z. I've said int. Yeah, that's right, indices are ints. Oh god. I've got to calculate which indices go with which vertices. So it has to follow the previous. Okay, top left will just stage across one by one. Yeah. Times vertex count is, isn't it? Okay. But we then have to go across. So that's plus. And that will be x. Yeah. That's right. So what I've done there let's have a look. Is, now that the cat's not looking, I might be able to use my pen better. So what we have is top left. We are going to have top right. So that's that point, and then we're going to have bottom left and bottom right. That's that point and that point. And then each time we go through these 4 loops, that jumps to there, that jumps to the next right one, that jumps to there, and that jumps to the next right one. And that's what this plus x is enabling us to do. So the plus x is every time we go through here, we are jumping across one. And then we go there, we add 1 to z, and that then jumps to there on the z, and then starts going across. Okay, so that's a very confusing diagram now, so let's get bin that. Thank you. That's a quick explanation of that. And why it works. So that's top left. I'm quite happy with that. Int do top right, which is top left, plus 1. Yeah. Oops. There you go. So now we can do int bottom left, which should be our other. Yeah, all we have to do is move down 1 z, as it were. So what we'll do is we'll take z and we'll move it down to the next one, and then we'll just do what we did before, and times it by vertex count. Okay. Got 2 opens, 2 closes, and then we just plus X, don't we? Yeah, okay. So we're just doing the same. And int bottom right equals bottom left plus 1. Right, so we've now got those 4. That outlines our square. Okay. Oh, let's try this. Let's do our indices. So indices. And all I'm going to do is pointer. That's right, pointer plus plus. So every time we use a pointer, we then add 1 to it for the next line. And that is going to be top left. So we're doing the first triangle now. We've got to do it in the right order, or if you do it backwards, it won't show because of face culling on OpenGL. So we've got to get it in the counterclockwise direction. Indices, pointer, plus plus. Two, 3, 4, 5, 6 equals. The next one will be the bottom left. Okay, that's looking good. The next one will be the top right. There we go, that's that one done. The next will be the top right again, because we're starting a new triangle. And then it goes to bottom left. And then we move across to the bottom right. And that's counterclockwise. There we go. That's everything. And those will all join up and make us a pretty picture. We hope. Right. That's everything then. We've got everything. This is where it's going to start getting funny. Oh, right, okay. And I've still got this squiggly line going on. Yeah, okay. What variables doesn't it like yet? M position. Oh, right, all of those are uninitialized. No, they're not. They're initialized here. Wonder why it's so slow at working it out. Is it the way I typed it in? Nope. It's just being a dopey. Oh, we're starting to get these though. Lovely. Alright, let's get this model sorted out. So, our model, m_model, equals a new amber our model. That's always obvious. Okay, that line's obvious. Now, our model is going to have whatever we needed. What did we need? These 2 things here. So, cut some out. Put some here. model, arrow, index count is the first one, is it? And there we go. That's going to equal what? Well, 6 times, open bracket, vertex count minus O1 times, open brackets, vertex count minus O1. That's how many indices we have. So there you go, there's 6 of them. Vertex count minus 1, vertex count minus 1. So that's how you know that's correct. What else do we need here? M underscore model. We need the VAOID. Okay, let's grab one of them then. And we'll make that equal to loader. And loader is a pointer. And we are going to ask it to send our data to GFX. And look at all of this data we can now send. Oh, lovely. Oh, well, that's easy. We can do it like this. We could do the first one, size of indices. That's an integer. Okay. Size of indices. Comma. Unsigned int. Indices. Oops. Yes, they are. Thank God for that. So it's going to be the address of indices 0. First address. Comma. What do we need to do next? Positions. So that's size of vertices, or our positions in this case. Comma. Yeah, unsigned int indices. There are 58,806. And vertices we have 30,000. Wow. Wow. That's huge. That is a huge model. Interesting. Did I do that right then? I don't know. Oh well. Get on with it and find out, shall we? There's only one way to find out, and that's to run it. Vertices. 0. Right, what does it need next? Int size of colour. None. Float colour. Null. Pointer. I'll do that. What's next? Size of texture chords. Followed by and texture chords 0. Do we need any more? Normals. Size of normals. And that's comma and whoops and normals 0. Yeah, that's all lovely. And I think I'll go with that. Any errors? It's not showing any. We have 30,000 normals, 20,000 texture coordinates, that's correct. 30,000 vertices, and 58,806 indices. Interesting. Very, very interesting. So something doesn't match up. I'm sure it should be 60,000. It is. Okay. It's... never mind. It's just one of those things. I'm going to leave myself a note here. Because we're looking at bytes. That's the actual size of in bytes, if you were interested. Equals size of type times vector dot size. And that's a different way of doing it using vectors. Excellent. All we need to do now is return m_model. And there we have it. So that's the model. You're still complaining. What we've got red down here. Alright, yeah, I think we could have a J there, I think. Yeah. That might help. You know, I can't see the red squiggly. Oh, it's there. Yes, it did. Expect a bracket. Goes there. That's good news. Alright, so I can save that out now. So we're all green on the right hand side instead of reds popping up. You've got a good idea now of how a flat terrain or a flat square can be made as a model, but we might need to actually get hold of one. So if I create a terrain, it'll go onto the model stack or model. We can load it in through the models. Let's have a look. So it's going to be used let's see. Here, initialize models. Split store, blah de blah, load models, split store 0, 1, blah 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 blah. Where's the actual saving of the model? Ah. That's an actual function that loads models. Okay. Here we go. Push back new model. So all we have to do is add it to TL3 shelf. We can add it at the beginning or at the end. Matters not to us. It would have to probably go in its own. Ah, yes, I think we'll call it Atlas. Interesting. Interesting. Now we've got terrain. We're not going to call it, are we? Not just yet. No. Anyway, I'm not going to call it just yet because there's obviously two faults with this. One is the squiggly lines, which have now come up, and I knew they would. And second, there's no get model. We haven't returned the model to anything or placed the model anywhere. It's just held inside here as part of this. Right, we can bring you back now. So we, at the moment, it's not actually part. So then it would be this instead of M model. We could inherit. Sorry, could inherit here. And that would save a big problem. Again, I'm returning the model here. No, we can't inherit then. It's got a new in it. And we've got this. Can we see it better on here? Can I get a plus on this? Resize it maybe. Alright, I'll read it out. Function uses 555280. Oh, I'm just going to copy this. I can hardly read it. Let's just go down to the bottom. Alright. Severity. Code description. So it's a warning. This is a warning? Okay. Function uses 555,000 bytes of stack. Exceeds analyzed stack of 16,000. Only by a little bit. Consider moving some data to outside of the stack and back to the heap. Blah 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 30. So yeah. How does this is what I was trying to get at. Differences in languages. What's the main difference between C++ and Java? Which is why I started off with this piece of Java code. What does that piece of Java code do differently to this? And the answer is an awful lot. Because that does not convert to this. They are not equal. An array in Java is more equal to a vector in C++. So how should this be written? Let's just make sure I don't need anything here. Okay. Alright. I'm going to think about that after because I've got enough to think about with this. So we can't do this. Because these arrays, although nice, aren't going to work. So we don't really need to know the size of them because we're going to use vectors instead. So this one converts to standard. I just wanted to show you the difference between what an array can do and what a vector does. A vector is just an array without a size. That's basically all it is. But it has some extra baggage that's on it to make sure that it works properly. And arrays work faster because they're held on the stack. And look at the size of those arrays. Yeah, this isn't going to work. Vector. So the first one is just going to be a vector of floats. So it's float star, because we don't want it on the stack, we want it on the heap. So we are making it into a pointer, and it's called vertices. There we go. Oh, thank you. Oh, what? Zuka. Zukashot 17. Yeah, Zukash. I know how to pronounce this, and I can't get my tongue around it. That's bad me coming from Germany, isn't it? Yeah, thank you. Big thank you. Shout out to you, mate, Zukashot. Fantastic. You're now a member, an official member of the C++ club. Feel free to use the chat, ask questions, ask about how do you do such and such a code. Don't need to stick to C++ on this on this line, believe me. We should see what I'm doing tomorrow. I do C++, this club on Mondays, Wednesdays and Thursdays at 2 p.m. British time. And Thursdays we're trying out Blades World, which is a look into my job and what I do in real life and my research and development. And on Saturday we do a Learn to Program, 2 p.m. onwards, so I'm a busy person. And on Sunday I go sailing with Naval Action, so that's 2 p.m. onwards as well. They're always at 2 p.m, so if you want, Tuesday's my only day off at the moment. But that depends on how tomorrow goes, actually, because I might have to move something. I might have to move my Thursdays to a Saturday. We'll see how that goes. And that equals that. So std : vector. So good to see you aboard. Welcome. I'm glad to see that people are taking an interest, actually. I didn't expect anybody to take any kind of interest in this. Normals. That's that done. And what's this one? That's the same, isn't it? Standard. Vector of floats again. And they are just going to be called texture chords. There we go. I don't think we've got a problem with the vertex pointer, but we do have a problem just down here with this one as well. So this is going to be a standard vector. So this is how you change arrays into vectors. And it's uint. It's going to cry now, because he doesn't know what a uint is. I made it up. It's an unsigned int if you have to type it in full. Actually, at this point I should, because I'm making it into a vector. Unsigned int. There we go. It's in blue now. But it's the same thing. And that's called indices. If you're wondering, it's in here. I'll show you what I did. So terrain.h to make sure everybody has it available. I have a system includes file which I have in a library called Amber. I use my Amber library, which I wrote myself. System includes peak. If you have a look, no, I don't want to peek at myself. Thank you. All right, go to document. Okay, so if I go to the document, it'll tell me that if uint is not defined, then define uint as unsigned int. So wherever I type uint, the compiler will swap uint for unsigned int. And that's just so I'm lazy. Yeah. I'm lazy and I type uint. There you go. So let's get back on with this. So just if you wondered what was going on there. There we go. Have we got anybody crying out? No, we haven't. So we'll delete that line. No, I don't delete that line. Do that. Okay, there we go. Oh dear. Oh dearie dearie me. So it isn't that. I don't even think we need a vertex pointer. No. I think we can probably get rid of that because the vertex pointer is actually an iterator that is inside the vectors, which is used inside there automatically. So we don't need to know it. All we have to do is push back a float. So it's vertices, just space off, dot push back. Push back means just push it on, put it to the back of the queue. If it's empty, well, it's obviously the only thing in there. So, yeah. And we want a pointer. So it's going to be a new float. That's going to look stupid, isn't it? I need the address or something. Do I calculate it? Or is there a different way of doing it? This part's so rubbish. This line's getting stupid. Let's get these up to date. Right. It's not going to let me do a pushback that way. With a dot. Because that would entail a new. And it would be a float. Are we getting seriously stupid now? Yep. I don't believe that's the answer. Seriously? Okay. So I need to put that goes in place of, where's the brackets normally? There, okay. Copy. paste. 2 brackets. And that's a dot pushback. So I could actually put the dot pushback in, couldn't I? Yeah. Okay, copy. Let's get rid of all of these. V. Same with normals. It looks a bit weird, but it's correct. It's interesting though, considering what I'm going to do to it at the end. Alright, we can do those ones. Okay, we're out with that lot now. Oh, the beauty of C++. But you can see how it's been constructed. I think this was a better way of doing it, because this way it shows you how it's being constructed. If I'd just written that line out, you'd think I was a complete and utter amazing person. But I didn't, because I can't. I have to work it through. Okay, so we're all in the clear up there. Have you stopped? No, he's not stopped moaning at me yet. Okay. Alright, so those are all news. We've still got this lot to do. So these are ints. Wow, this is going to look really weird. I've never done it like that before. Unsigned ints. That's correct. Unbelievable. Weird. It's got to be the weirdest thing you'll ever see me do. And I'm hoping I'm not going to put a copy and paste error into this code. I hate the damn things. There is no excuses for a copy and paste error, ever. So that, and it's 2 at the end, isn't it? Yeah. Can you get out of that? Oh, stop it. Catches you into things on this, which is annoying. So I'll separate those off. Separate those off. Separate them. Lovely. Job's a good one. There we go. Glad I didn't build before. Now we've got problems here. It's now a vector, isn't it? Yeah. You have to have a second one on. That's okay. It's a pointer, so it's a pointer to the beginning of the data. So we've got a vector of pointers pointing to data. Yeah, so there's 2 parts to it. So that should do that. Now, these have all changed. Where's it getting that from? that doesn't exist anymore. It's a vector. It's size of type times vector dot size. So let's go to the top one. Size of indices. Unsigned int. And then it's multiplied by indices dot size. Ta-da! Not a difficult one there. These are vertices, they are floats. Times, this is vertices, isn't it? Dot size. There we go. What's that one? That's still the same. Texture coordinates are floats, aren't they? Yeah. That's correct. And the last one, normals are floats as well. And that's just normals. Dot size. Lovely. So that's everything there, and that's why I had that note at the bottom. Close. I need a drink. Where can I need a drink? I've just had a thought. What happens if this channel gets to 50 people? Some silly Twitch thing happens, doesn't it? Where you become... well, supposedly some kind of moody thing. I don't know. I've never done it before, so... There we go. That's an interesting idea. I mean, we're up to 47 people, so... The club size is growing, so I'm hoping chat will grow and people start swapping ideas and stuff. That's the whole idea that I've got, anyway. In the meantime, I'm definitely going to be doing some code once the channel grows. I think I'm nearly ready. Is this ready? No, it's still got all of that stupidity in it. Okay. And I've got red dots now. And it's on these, yeah. That's fine. We'll just add brackets until it stops. Another one. Go on then, you can have another one. Fussy texture coordinates. I don't know. Always crying. Right, I'm going to try for a build. I've got one. Oh, it's gone. It's just gone. Literally then. Yes. We are within stack limits. If you're not in stack limits, then you go to a web page called Stack Overflow and find out what happens. 0 failed, 1 success, but as expected, we got an error list. And let's have a look at it. Oh. Did I do something as stupid as that? Yes, I did. Okay, I think we can get around that one. Next on the error list. Oh, God, no. What? Argument conversion from size t to int. Possible loss of data. I thought this was unsigned. It's an unsigned long. Where's it coming from? It's coming from here. Yeah, there's a size T. Oh, cobblers. And it's right. Oh no, this is horrible. All I'm going to do for now is a reminder to myself, I think. Because it's going to start looking horrible and I want to sit down and do it properly. I don't want to be under any kind of pressure on that one. Problem when you're streaming is you're always under pressure. And it's weird. It's a weird kind of pressure to be under. Especially for me, because I don't have any in my life. I forgot to open one there. Wow, that's a first for me. Closing them. It's usually a different story. That's okay. That's okay now. Thank you. So I've addressed that one, but not properly. Pointer, local variable, initialized but not referenced. Thank you for reminding me. Yes, we don't use that anymore. I think I've gone through this. That is a horrible mess now. Let's just do a rebuild. Yeah, it's closed its mouse, but it's not correct. Doing this to say, please convert whatever's in the brackets to an integer, and I mean to do it, is wrong. It's correct in Java. It's not correct in C++. What you should be doing is, which is what I'm going to show you next, is static cast. There's different types of casting you can do. Static just means do it in place. Okay. There's your type, there's your bracket. So that's what it should look like. So what we'll do is we'll replace it with the correct way of doing it in C++. So that's Java int. It still works in C++ 11, but I want to go with C++ 17 and onwards. I want to be more modern than that. The number is the year. So this is correct for 2011. For 2017 they changed it to that, which is very handy and nice of them, but it means you've then got to learn all about casting, unfortunately, and the different types of how to cast from one type to another, in this case float to int, size t to int, and what that really means. That's actually tidied it up a bit. The lines are way too long now, though. It's a damn shame. means I have to break the lines. It just looks weird. Because this is the main reason why we're doing this, is this one command. The whole of this class comes down to that one command. If this fails us, everything fails. Now, the only other alteration I'm going to make, now we've got this working, is I am actually going to do Amber. I don't like this, but I'm going to do it. Because this is what people are taught to do. I still don't like it. Oh well. I don't like doing it. It's a getter. How many times do you see me use getters and setters? I'm so against them. In fact, I am so against this one, I'm not going to do it. I'm going to show you what I would do, not what you got taught. I would go here, and I would say public. And why is that wrong? That's what I would do. What that enables you to do now, I can show you now, can't I? What it enables us to do is write our model warehouse slightly differently. So let's have a look. Model warehouse, where are you? You're in the library, aren't you? Yeah, you are. Didn't mean to do that. You're in core. Right, I've got a problem then, haven't I? I have to pass this in. Okay, so I want a new thing in here. We've got initialize models, prepare models, load models. Got nothing in private, have we not? Okay. All right. Where's our vector? We're bringing it in through prepare models. That's the entities. Where is our model list? Where are we putting stuff? There. Right. Can we therefore get rid of this line now? It's not been used, so we can get rid of it. Okay. We are going to have we're going to be doing it the wrong way round to start off with until I've decided that it was working, but hey ho. We are going to have another model. Yeah, a model will do. Star. And And this time we're going to call it M underscore terrains. Yeah, I'm going to put it with a big capital letter as well because these are important ones. Okay, we're good. We're already good. So where it says prepare models, we can inject another have to be careful because we haven't even written the terrain shaders yet. How is this going to go in? I'm working at this the wrong way around now, aren't I? Prepare models will send it through to the batch renderer. And there it is. Prepare models, blah de blah de blah. Else render process color model, process texture model. Well, we're not going to have another if. We're just going to do another for statement here and do the same for terrains, but we can't do that because we haven't got that rendering. We need to do the renderer for it. How it will then look is it will get passed into here. I am not happy. Do I need to keep them? This is a pass-through. Yes, I do, because entities get sent in, models do not. Correct. So we're going to break the rules. The terrain should be created here. Somewhere. But it needs a location. So it's in initialize models. It's in here. Yeah. Where this one actually gets all the models and loads them. Okay. I think I've got it. If we back out of here, because this is the library, we now have to write the library functions to support the model, and that means this bit here as well. We are going to have to initially just make a terrain and throw it through, I think. I think that's fair enough. Yeah, we're alright. We're building. So where are we going to include it? We are going to include it in the state, the game state. So I can close all my rendering and gibberish off. So I'm going to have to test it in the game state before I go ahead and start building more library functions. I want to test this out. So let's get rid of you lot. And we are going to go with game state and game state header. Okay. So I've already got entities avatar. Why does it keep putting these automatic double slashes in? Is this a new thing, by the way, that I don't know about because I haven't read the 2019 version of C++ for include files? Because it's starting to bug the hell out of me. I should stop using this editor. It's rubbish. Shouldn't say that, should I? See, look, it's done it. I didn't do that. Okay. I'll go into entities. And we'll have terrain.h, please. Thank you. Now, I know the terrain's going to be big. So what we're going to do is we are going to put it up here. What did I call it? RPG? Yeah, we're in the same thing. I'll call it terrain. I need to distinguish. Yeah, that'll do. I can't say that it's not a model. We are going to have to put a texture in there, aren't we? Yeah, we are. Have I got a texture? Anybody any ideas? Oh gosh. Resources. Let's see what I've got in resources. I've got some textures here. And got blue, gold, red, gold, intro. Oh, I've got a terrain one. I've got a terrain PNG. Why have I got a terrain PNG? I don't know. Oh, well, we can use it still. PNGs and JPEGs both work. Oh, PNG-E. Yeah. Right. Oh, I remember now. I changed them all to PNGs, didn't I? Because it was a smaller file size. But yeah, we've got some green stuff there. We can load that. Okay. Right. Let's see if we can use it then. Let's have a look. This is all about the entity, isn't it? But it's got to be done before that line. Because it has to be passed in here. Alright. Because I'm about to take these all out completely. If this works, these get taken out. Yeah, okay, because I can stick some trees on it for reference of movement. Yeah. Alrighty. Decided. And it's terrain model equals a new terrain, open brackets. What do we need? We need an atlas. Okay. The first atlas position will be 0, 0. So, okay, I can put that in. These are integers, so 0, 0, 0. These will be changing. Amber store obj data loader. Who the hell's got that? Nobody. It comes under OBJ stuff. I thought by now... Oh, that's right, I separated it off into a... That's right. Okay. Alright, we're going to have to make this into a bigger thingy. Never mind. I was hoping just for a small note. Not one of these big ones. Okay. Hash include Amber. And it's going to be OBJ data. And store OBJ data. Yeah. That one. Is that a structure? Let's just go and have a quick look at it. It is... Yeah, it's got the full structure. I want to make sure I'm not messing myself up here. Thank God. Because that's the only thing I want out of it there. Alright. Yeah, I can make one. That's fine. We'll make one. That's okay. And that means we are going to have an Amber. Ooh. Colon. And it's store. That one. And I'm going to call it... I'm going to call it terrain loader. Because it'll make more sense. Okay. Finish you off. Sorted. Okay, so here we now need... Oh, wish it wouldn't do that. M underscore terrain loader equals a new Amber thingy store OBJ. Although it's not an OBJ, I know it's not an OBJ file, I'm still cheating by using it. And that means that this one now becomes M underscore terrain loader, comma, int texture ID. Oops. We need a texture. Who's doing textures? We aren't doing textures at all. Well, we're not getting a separate load up of textures. We're getting the ones from the models. I do have a texture loader though, don't I? Sneaking around somewhere. So yeah, we'll have terrain. It needs to be stored onto the graphics card with the other terrain, with all the other textures. Okay, so what we'll do is we'll make that texture I don't know. 0, 1. Don't know. What is it? An unsigned int. Okay. Wait a minute. Yeah. And we're just going to call it terrain texture. And we're going to set it equal to 0. It looks silly, but it don't matter. I know what that texture is. It's one that's being loaded from another model, which is beside the point. For testing, anyway. Do we need anything else? Oh god, we need a UUID, don't we? Holy dingoes. Who's giving them out? We certainly aren't. So my UUID I'll have as 1, 2, 3, 4. Hello. Anything else? No, okay. Actually, can't reach, can't do that. Oh. What's that then? I've never seen that before. Data 1, 2, 3, and 4. File guide def.h. Interesting. So, I'll just have an ID. That's a safer bet, isn't it? Let's just give it an ID. Told you we're going to need to do these now. Unique, yeah, that's a uint as well, isn't it? Yeah, it is. Actually, we could do terrain. ID. There we go. Right, so that's how it would look. Those are the bits and pieces that we need. Now, how we would use it is another matter. So let's have a look at that, shall we? So once we have this terrain model, yeah, we can send it straight across. So we would store the terrain model. Probably. Don't know, no certainties at this point. By adding it to a map or a vector? Vector, probably. Vector of... Actually, no, it's a map, isn't it? Oh, it doesn't matter. It's got a terrain ID, it's got a texture ID. Yeah. Yeah, it's starting to work now. Starting to work now, yes. Adding it to a vector of maps in the atlas, which we haven't got yet, but we're getting closer to now. Current map equals avatar's location. We know that. And that's it. We now have a terrain model. So, m_terrain model, and this is where it becomes really fun. Oh, we've got a terrain loader and a terrain model, huh? Okay. It's a pointer, and look what we have here. You don't need a getter. If you remember, I just made it public. There you go. That's why I don't use getters and setters. I now have all of its information. Okay. So I don't need to get it. What I could now do is something like, let me just do that for a minute. Stops it complaining. On initialize models, you could put in here that value straight into here and initialize it through that way, or this could already, this part here is more likely to be in there. I think all of this goes inside initialize models because that's the entry point where it's going to be needed. But initialize models itself needs to know where the avatar is. Alrighty. And we don't. That's just a model that we threw out so we could look at it. I know it's at 0, 0, 0, 0, but that's irrelevant. It's also facing the wrong way for this. So that's what gets my attention there. Do I have a logging system here? No, I don't. Alright. Need to know this works. It'll delete itself. I didn't look at that, damn. Oh, silly me. Oh, damn it. I didn't do a cleanup. Do you remember those few thousand floats that we got knocking about back out in memory? We never deleted them. We sent them off to the graphics card. They're on the graphics card. Well, we don't need them anymore. So quickie to do. Clean up the vectors in terrain.cpp. see what else we've got now. Is there any piece of information in there that would be relevant? Yes, there is. So what I want to do now is see out. I want to find out whether it worked. Theoretically, anyway. Why is that wrong? Oh God, I hate this system with its red squigglies. What we'll do then is we'll take you. Don't need that. And see if we can get a test in here. And the dumb thing is that. Yeah, okay. And we're going to try. If it gets one, knowing it's worked. Terrain, model, VAOID. Hold on. Alright. Oh, I forgot. Oh. No, just do that. It's easy. Control B. It says it's worked. Do we believe it? I mean, we're still doing things for a while there. Oh God, this is so weird. Alright. Who's up? Sandbox. It's getting pretty big, this sandbox thing. Oh, that's because I've got textures up. Don't need resources open. Alright, I've got a feeling we can go for a run on that. Yeah. Let's see what happens. Ooh. And I know why. Because the information I gave wasn't available at the time of... It's here. It says it here. It's just about to assign VA01, and what happens? It finds out that, yeah, there's nothing there. Let's just track that back up. Ooh, call stack looks awful. Bind indices, data to GFX. Where's it being called from? Terrain. So let's have a look. What's wrong with that line? Why is VBOID 1 incorrect? It's usually the line above that's not correct. Is this an OpenGL one? What is that? I'm just trying to decide what it's actually trying to do. It's input output. For something. MVBS, yeah, okay. Element array buffer, SI, size, yeah. That's an interesting one. It did the VAO and then couldn't do the VBO. I wonder if it's this 235,000 bytes I'm asking for. That's a bit too high. We didn't have a 23,520. Hold on a minute. Yeah, okay. Interesting though. So yeah, our terrain is causing a problem. Oh, bless. That is fantastic. The problem isn't with store object data, I don't think. Just wondering if I could... I know it's coming from within this, so that's not the thing. That's not what I'm thinking. Ah. Yeah. That has to be 0. It's going to conflict. I need to write I'm going to have to write the shaders. Nothing else for it. I'm going to have to write the shaders. I know it's working because it crashed. But until I can get an ID and a texture ID, no textures have been loaded at this point. So I suppose we could get rid of... Might be able to get away with a 0 and a 0. Just don't tell anybody I did that. I doubt we'll be able to do it. I don't think I can brute force my way into loading it. No, I can't. It just doesn't exist. It's doing things out of order. That's alright. That's fine. As long as I know. It's going through the wrong way. Yike. Because until we initialize initialize models here, that sets all of that up. So we're going to have a separate one for initialized terrain. Oh no, we want to put it inside there. Oh. And that's where we are for next time, isn't it? I've just had a nice idea. Yeah, okay, I'll look at that. Alrighty. Any questions? Anything people want to know? Is like, this is not my daily job. This is just me holding like a club meeting every couple of days. For you lot, I mean, is there anything that you want me to cover in the next episode? I mean, otherwise I'll be doing this terrain, be putting my terrain model in. The component for the ECS system worked. Everything was sorted out there. I found out what... I'll just go over, because it was at the start of the video that I did this bit. So I'll go over what happened on Wednesday. At the end of Wednesday, I was in a conundrum like this, but it was with moving the avatar. Let's just have a look. Quick. Where is it? Close solution. Close the windows as well, please. Alright. This is my off-screen mess about. Different version. Totally different, but this isn't 3D actually. This is all in 2D. So, as you can see, it works perfectly. He's up here, he's just moving. But, if you watch, he has that slight sluggish kind of movement to him. So the acceleration and deceleration, when I take my finger off the keyboard, he doesn't stand still. It looks as though he moves and then comes back a little bit, but he doesn't. It's because he decelerates to a stop. So you get that little kink bit. It's a visual incontinuity. And I know that's small. It's because this is a sandbox kind of playground for me. For developing the CS systems. So that's the movement one. So it works fine, absolutely fine. It's all the same code, except it's in XY instead of XYZ. That's all. Okay, so that's that. So as you can see, it all goes through player idle. I'm looking at animation for that, but this is all 2D. The animation that I do for this one will be nothing like what we do for ours. It'll be completely different. So yes, I'm doing a different one at the same time. I'm doing a 2D version at the same time as 3D. But that's for different reasons. Close that solution. And tomorrow, I don't know what's going to be happening. Because originally, I was supposed to be doing a learning course for you lot. I don't know if anybody online here now has seen one of my Saturday shows. It's the learning with blades type of thing. I'm using some strange language, but I've just lost everything. I'll show you. I'll show you what happened. You'll really laugh your socks off at this one. Where can I show it from? There we go. Here. Okay. This is my disk management screen. Alright. If you have a look at disk 1, this is where all the programming's done. Here. And it's supposed to be in 2 halves with Windows 10, which is what we've got here, and my usual Linux on the other half of the disk. And as you can see, even if I widen this up, it's not there. So, luckily, me being me, may have saved the day. I'm not saying I have. I'm just going to check in with you that that what I'm doing is going to be okay. So it's IntelliJ we were using, wasn't it? And we were doing JavaScript, was it? Yeah. So that's Saturdays. We're just messing around in JavaScript, learning how to program. And I was trying to do unit tests and stuff. Oh, here it is. It's decided to show up. Oh, good, I can close most of this other stuff down now. Can close you down. And yeah, that's a bit loud. Here we go. Oh god, that's massive. I wish it wouldn't do that. So this is what I've got left, what I've been able to recover so far. And I think we were up to doing, well, we've just done Vec 2. So we've done all of these adds, subtracts and stuffs and rotates and bits and pieces. But I've done all the tests for them. So what I'm thinking is rewriting all the tests tonight and then continuing with the series tomorrow. If that's not possible, then I'll probably have to change over to what we do on a Thursday. But otherwise, that's the outro music. Means I'm off. Thank you, viewers. Thank you for popping by. Thank you to our new followers. Fantastic name there, Zukushude. Yeah, I'll get it right one day. In the meantime, I just want you to all take care. I want you to keep coding, trying different things, making your life a better place, making the world a better place, and of course, having fun.